హాయ్ ఫ్రెండ్స్, ఈరోజు మనం పోర్టర్ గవర్నర్ ఎఫర్ట్ అండ్ పవర్ దానిపైన మనం ప్రాబ్లమ్స్ ఎలా ఉంటాయి అనేది ఇప్పుడు చూద్దాం. సో లుక్ ఎట్ హియర్, దిస్ ఈస్ ద ప్రాబ్లమ్. అండ్ నౌ ఏ పోర్టర్ గవర్నర్ has equal arms, each 250 mm long and pivoted on the axis of rotation. Each ball has a mass of 5 kg and the mass of the central load on the sleeve is 25 kg. The radius of rotation of the ball is 150 mm. When the governor begins to lift and 200 mm, when the governor is at maximum speed, find the range of speed, sleeve lift, governor effect and power of the governor in the following cases: when the friction at the sleeve is neglected and when the friction at the sleeve is equivalent to 10 newtons. See this is a problem. And then now here, how to solve this problem we are going to see. First we are going to write here solution that is given. Before going to this, you draw Porter governor. We know Porter governor free body diagram. Now I am going to draw this free body diagram for Porter governor, and now this is called P. This is called B, ball, and this is the distance is given 150 mm. So this is the point is called G. So now here the link is 250 mm, and then here the link is called D. So this is also called 250 mm is given, and then now here this is vertical force M into G. This is sleeve force acting capital M into G by 2, and now the G to P, this is the height, is given called H1. So this is a minimum position. So then we are going to see here maximum position. We know very well this is governor axis. And then now here maximum position, I am going to take this. Here is B, here is called G. So this distance is called 250 mm. Look at this, this is 150, here is 100 mm, will increase the radius. Then this is B, this is M into G. Automatically what happened in here, this D distance will increase. This is called sleeve height, that is sleeve height X. And then here sleeve force, this sleeve force is capital M G by 2. Now the B to D is coming to one link. The link will not change the distance, though this is fixed 250 mm. And similarly we take here also provide P. This is also similar distance, the link is similar. So then 250 mm. So now P to G, here is taken, this height is called h2. So now I am writing here B, this is called maximum position. Okay, so now here we are going to write B given data. So first BP, okay, first I am going to write here BP, that's it, take that is equal to BD, so 250 mm, and the small m is equal to 5 kg is given, capital M is equal to 25 kg, R1 is equal to 150 mm, R2 is equal to 2, oh my god, this is given 200 only, so 200 mm, and then F is equal to 10 newtons. Okay, so first one, when the friction at the sleeve is neglected, when the friction at the sleeve is neglected. So first of all, let us find the minimum and maximum speed of rotation. So the minimum and maximum position of the governor is here shown. This is minimum and maximum. Okay, and then now we are going to see here N1 is equal to minimum speed and N2 is equal to maximum speed. So here we take this minimum position. Here I am going to write H1 is equal to PG. So that is whole root of BP square minus BG square. Then here I substitute these values, minus, that is equal to 200 mm. Okay, that's we are going to convert into meters, 0.2 meter. And similarly, we are going to take diagram B maximum position. I can write H2 is equal to PG is equal to whole root of BP whole square minus PG whole square. And then now here whole root of BP is equal to 250, that is same, and PG is equal to 200. mm. So then this is called 0.15 meter. Okay, and now we know N1 square is equal to M plus M by M into 895 by H1. So now substitute this all values in here. 5 plus 25 divided by 5 into 895 divided by 0.2. That is called H1. And then now here we are going to calculate this. You will get the answer 26,850. Okay, and now whole square, then it will come N1 is equal to 164 rpm. Similarly, we are going to take N2 square m small m into 895 by h2. So here also I am going to substitute all values. 895 h2 is equal to 0.15. okay, so then you calculate this, it will come around like this, and now finally N2 is equal to 189 rpm. okay, so this is the problem. Now we are going to see here range of speed. Now we are going to see range of speed. We know that range of speed, that is equal to n2 minus n1, then 189 minus 164, so 25 rpm. This is the range of speed. And then now we are going to see here sleeve lift, x value we need to find here, and then now x is equal to 2 into h1 minus h2, and that is equal to 2 into 200 minus 150, so that is given from here 100 mm, so then that is called 0.1 meter. okay, so now here governor effect, and the next one we are going to see here governor effect. So let C is equal to percentage increase in speed. So we know that increase in speed or range of speed C dot n1 is equal to n2 minus n1, that is called 25 rpm. Then C is equal to 25 divided by n1, so 25 divided by 164, that is called 0.154 is the C2 value. okay, C1, C, just a C, okay, small c, you can take small c. okay, so therefore C is equal to 0.152. there is no units. So now we know governor effect. So we know the governor effect in here P is equal to C into M plus capital M into G. okay, so then that is equal to 0.152 5 plus 25 into 9.81, so it will come 44.7 newtons. This is the effect of governor. okay, so now see here power of the governor. Now power of the governor, then power of the governor, that is P into X, that is equal to 44.7, that is called C into 0.1. okay, so this is called 0.1. what is 0.1 is coming from here, X is equal to 0.1. okay, then X is equal to 0.1, P is equal to effort, that is called 44.7, and then now we will get this here is 4.47 Newton meter. okay, That is the first condition. And now we are going to see second condition, when the friction at the sleeve is taken into account. So then here we know N1 square is equal to M into G plus capital M into G minus F divided by small m into G into 895 divided by H. So 1. So 1 is the, so 1. Now 5 into 9.81 plus 25 into 9.81 minus, okay, F is equal to 10 is given. M is equal to 5 into 9.81 and 895. H1 already found 0.2. Okay, now we calculate all those things. 25,938 it will come. So N1 is equal to, therefore N1 is equal to 161 RPM. This is the difference. Okay, and now similarly we are going to find out N2 value. So N2 square is equal to M into G, capital M into G plus F divided by M into G into 895 divided by H2. Now here M is equal to 5, G is equal to 9.81, capital M is equal to 25, G is equal to 9.81, F is equal to 10. The only value can change in here is only H2. The remaining values all are in same. Okay, now H2 is equal to 0.15. So then we calculate this. It will come around like this. So N2 is equal to 192.4 RPM. So the similar case of here, so range of speed, that's N is equal to N2 minus N1, we know very well. So (161). Okay, now here RPM 192.4. Okay, right, yeah, 31.4. This is the answer in here. And now here sleeve lift, we are going to see here sleeve lift. Therefore that X is equal to 100 mm, that is 0.1 meter. Why? Because the sleeve lift X will be same as calculated above. Okay, so therefore X is equal to 100 mm, that is called 0.1 meter. Next we are going to see here governor effort. So then here governor effort, this is coming from here, C is equal to percentage increase in speed. So we know that in speed of range of speed, C N1 is equal to N2 minus N1, that is equal to 31.4 RPM. Then here small c is equal to 31.4 divided by N1. So 31.4 divided by N1 is equal to 161. So the C value is coming here 0.195. And next here governor effect. So now we are going to see governor effect. P is equal to C into M into G plus capital M into G, capital M into G plus F. Then here C is equal to 0.195. So 5 into 9.81 plus 25 into 9.81 plus 10. Okay. So calculate this, we'll get the answer 57.4 newtons. Okay, this is the effort of governor. Now, next we are going to see here power of governor. Power of governor, that is equal to governor effect into X. Then governor effect is 57.4, X is 0.1. So then this is called 5.74 Newton meters. This is the power to calculate. Okay, this is the procedure to solve the problem with governor effect and governor power. The condition here is, the first condition, when the friction at the sleeve is neglected. Ikkada sleeve anedi neglect cheyabadappudu em jarigindi. Here when the friction at the sleeve is taken. So friction apply ayinaka vachina value. Without friction you can take this. Okay, so this is the procedure to solve this. Okay, and in next class we are going to see some more problems about this. At the same time controlling force. Okay, yes, maybe we can take some 2 or 3 classes. We are going to complete this unit, I think. Okay, right, thank you.